Okay, so good morning, everybody. Today is week 4 of our summer school. That means we only have one more week after this, which is really, really good. That'll give you like a month before school starts. However, school is going to start, nobody really knows. There'll probably be some sort of live component to it, but I know as much as you do, which is not much. Okay, so today, this week is going to be a little bit different. This week's project is a short project. Okay, it's like a paragraph. It's not a long thing. So instead of this project being due next Monday, this project is due on Thursday. Okay, we got a little bit of insight towards the end of the summer school thing, and it looks like they want grades complete and done by next Friday, August 7th at noon. Noon is when class ends, right? I can't have you guys turning in the project that day because I won't be able to grade them in time, okay? So the way this is working, this week's project, which is going to be the water cycle, we're going to talk about all of the processes of the water cycle. It's not going to take too long. And then this week's project is going to be due on Thursday. So Thursday at 11 a.m. So before class on Thursday, the project will be due. Okay. That way on Thursday during class, we can start the next one. Okay. So there's not going to be much time to work on this project, but again, it's a very short project. Okay. This Thursday, we're going to start working on our next project. Our next project is a volcanoes research project. It is due next Wednesday, August 5th. Okay. Maybe Thursday. I might give you until Thursday, but they have to be in by Thursday the 6th. Absolute latest. Okay. I won't be able to grade them all if I get them on Friday. So they have to be in by next Wednesday, next Thursday, the 5th or the 6th. Okay. So that's what this week is looking like. We're not going to have a lot of time at the end of this week to just kind of do some work. But we're going to have tomorrow and Wednesday as just working days. Okay, I'm going to go through all of the processes today, and then tomorrow and Wednesday can be working days, and then Thursday we start the volcano project. Okay, so without further ado, let's talk a little bit about the water cycle. Water cycle, you've learned about since probably 3rd grade. It's something that you probably learn literally every year in science because it's important. The water cycle, water is important. Can we live without water? No. Right? Water is super important. So you learn about the water cycle all the time because plants need it to survive. We need it to survive. This planet is incredibly unique because it has water on it. No other planet in the solar system has liquid water. And it affects rocks and the landscape in a very drastic way. So the water cycle is really, really important for everything we talk about in science. So it's natural that we learn about it every year in science, but kind of through a different lens. Okay, so what is the water cycle? Very simply, arrows. Water cycle is just the process of water moving around the environment, right? Does water stay in the same place? No, water goes everywhere. It evaporates up into the sky. It falls down to the ground as rain. It's in rivers, it's in the ocean. It's underground. Water is literally everywhere. Okay, so what's the water cycle? The water cycle is that process. It is how that water moves around the environment. How does it get up into the sky? I don't know. That's part of the water cycle. How does it get into the ground? Also part of the water cycle. So what we're going to talk about today is those processes. There's 6 processes. 6? Can you guys see that? 6 processes. And we're just going to go over those. What are they? What do they look like? Basically it. Okay. So the water cycle is translated poorly. One of our pictures got in the way. The water cycle is driven by energy from the sun. Very important. Water cycle doesn't exist. The sun doesn't exist. Okay. Driven by the energy from the sun, the water cycle is crucial to the existence of life on our planet. Right? There's no life without the water cycle. There's no water cycle without the sun. Everything's connected. Everything. Okay. This is a little diagram of the water cycle we're going to be looking at through this little talk. You notice it's got 6 little blanks on it. We're going to be filling this out as the lesson goes on. Okay. So we're going to start here with 1 and 2. These are probably, one of these is probably one that you're very, very familiar with because you've learned about it since 3rd grade. So we start with, how does water leave the surface and go into the atmosphere? This is where the sun comes in. Without the sun, we don't start the process. So the sun heats up the ground, right? If you guys go outside, it's going to be 95 degrees today, so you won't have to be outside for long to feel this. You go outside, you feel the heat of the sun, right? Well, so does water, right? Water absorbs that heat, and if that water absorbs enough heat, it begins to do something called evaporate. And evaporate, it's just that water changing from liquid. So like if you go outside and you look at a puddle, it's liquid water. And if you shine the sun on it for a little while, that liquid water will disappear. Does it just disappear? Does it vanish into thin air? Kind of. It turns from that liquid water to the gaseous form of water. So it changes states from liquid to gas. Okay? And we call gaseous water water vapor. So evaporation is just that process of having like liquid water, a lake, the ocean, a puddle, and that water gets heated up and it starts rising up because it's no longer a liquid, it becomes a gas, and gases tend to rise up into the sky. Okay? So evaporation is that process of the liquid water changing to gas, and then that gaseous water going up into the sky. Okay? That's evaporation. Transpiration is very similar to evaporation, but it requires plants and trees. So plants and trees, what do plants and trees need to survive? They need CO2, carbon dioxide, they need sunlight, and they need water. Okay, they need those 3 things, okay? Trees are full of water, right? That's what sap is. Sap is water that's in trees. And what happens is that there's water in the leaves, there's water in the bark, there's water in the branches, and leaves and branches and stuff have holes in them. They're called stoma. They're just little holes in the leaves. And water, being really, really tiny, can escape from those holes. So basically the plant is losing water because the heat of the sun is shining down on those leaves, and the water escapes out of those holes and goes into the sky. Okay? So basically, if you just want to think about it simply, all transpiration is evaporation, but not coming out of a puddle, coming out of plants and trees. It's just water leaving plants and trees and going up into the sky. That's transpiration. Easy. Okay, so here is our little diagram of the water cycle. So right now we're starting over here. We have the sun shining down, and it is evaporating. It's heating up that surface water, so it's evaporating up into the sky, or it's heating up those trees, and the water is escaping those leaves and going up into the sky. So just think of evaporation as the beginning, as the water rising up into the sky, either from a lake or a river or a puddle, or from a tree or a plant. Okay? First 2 steps, evaporation or transpiration. So, once that water evaporates, what happens next? Well, if we look here on our diagram, we can get a little clue. What is this big thing in the sky? Is it a monster? I hope not. No, it's a cloud. So how does evaporation, transpiration, how does that water vapor, which is invisible, we can't see water vapor, how does that water vapor become a cloud, which is visible? You can see a cloud, right? Yes. Okay. So how does evaporated water form into clouds? Very simply, it's just a process called condensation. So as this water vapor is rising up into the sky, it begins to cool, it begins to expand, and it starts to condense, okay? Last week, you learned a little bit about how clouds form and why do clouds form at low pressure? Because as it's rising, it's expanding, it's cooling, and then it starts to condense, okay? So condensation is the opposite of evaporation. If evaporation is going from a liquid to a gas, condensation is going from a gas back to a liquid. Okay, just a reverse process. Okay, so condensation, the process of water changing from a gas to a liquid. If you have a glass of water nearby, especially right now, there's probably some condensation on the outside. It's just the water that's like on the outside of your Coke can or a glass of water. Where does that water come from? Is it leaking out of the Coke can? No, that'd be a really bad Coke can, right? No, it's coming from the air. There's water vapor in the air, and it cools down around your Coke can, and then it starts to stick to the outside of it. Okay, that's condensation. The process of water changing from a gas back to a liquid. And that's what makes clouds. Clouds are liquid water that are floating up in the sky. The wind is pushing them up, so they kind of stay up there until it starts to rain. So how does that condensed water, clouds, return to the Earth's surface? Through a process called precipitation. And precipitation is just water coming from clouds, going back down, back to the ground. Okay, this is liquid water or solid water going from the sky back down to the surface. Okay, the most common form of precipitation is rain. Rain is precipitation. Also, other precipitations, we got rain, we also got snow, we got hail, we got sleet, we got freezing rain, 5. There's probably a couple more that I'm forgetting. But really anything falling from the sky and coming down to the surface of the Earth is going to be precipitation. Okay. An asteroid, not precipitation. But any form of water coming from the sky, precipitation. Okay, so let's look at our little diagram again. So we start here with the evaporation and transpiration, water coming from the surface, rising up into the sky, right? It is now water vapor. We can't see that. But as it goes up into the sky, it starts to cool down, and then it condenses back into liquid water. And when it does that, it forms these white puffy things that you see everywhere. Those white puffy things we call clouds. Okay, so condensation is the process that forms clouds. Okay, eventually those clouds get really heavy. They get really, there's just a lot of water in them. Okay, and the wind blowing up from the surface can't keep them up anymore. So what's going to happen is that water that's in that cloud is going to drop down to the ground, and that's precipitation. So far, we started here on the ground, went up into the sky, condensed into a cloud. That cloud kind of traveled along for a little bit, and then the water in that cloud starts to rain or snow as precipitation. Okay, so now we're back down on the surface. We started on the surface, we're back on the surface. After precipitation, we're now on the surface of the Earth. Okay. So now we're on the surface of the Earth. What happens now? 3 things. No. 2 things. Okay. So the big thing that can happen is something called runoff. Runoff is the process of water running off, kind of flowing down the surface of the Earth into a body of water, like a lake, a river, a stream, an ocean. So water is rain or snow or whatever that hits the surface of the Earth and stays on the surface. It doesn't go into the ground. Okay, it stays on the surface and it runs along the surface, usually as like a stream or a river, into another body of water, like a lake or an ocean. Okay, so this is water that stays on the surface. Some water, we're going to find out in a second, goes underground, but this water stays on the surface of the Earth. Okay, and it runs off the surface right? If you've ever been in, like walked along the sidewalk after a big rainstorm, you're gonna see water in the street gutters going down. That's runoff, right? It's just staying on the surface, going down the street, eventually to probably a river or a stream, okay? Streams, lakes, and oceans, these are bodies of water in which the water runs off into. So if you see water running off, it's probably making its way to a stream or a river or a lake or an ocean, okay? Or if you live someplace very, very cold, like Antarctica or high up in the mountains or Greenland, what happens is they don't really get rain, they get mostly snow, right? So that snow is going to fall down and it's going to accumulate as something called a glacier. Okay, and a glacier is a frozen river. I say river in quotes, it's not actually a river, but it is a big piece of ice that flows down very slowly down mountain valleys, or it can cover an entire continent. Okay, a glacier like Antarctica or Greenland cover the entire continent. Okay, there's also glaciers high up in mountains that kind of like flow down those mountain valleys from the peaks. They look like rivers, but they flow like a mile a year, which is very slow. Okay, that's a glacier. And eventually, if the glacier gets down to a point where it's warmer, the glacier starts to melt, and then we have surface water again. Okay, so that's what can happen. One thing that can happen after it reaches the surface. It can just run off the surface into a lake or an ocean or a river. Okay, so now here we are. We got, coming from the ground, we got evaporation and transpiration, going up into condensation. That condensation is going to form this cloud. That cloud will get heavy and it will start the rain. And one thing that can happen is that rain can run off the surface of the earth. What else can happen? It can run off the surface of the earth, but like I hinted at earlier, it can also go into the ground, okay? And that process is infiltration. Okay, infiltration means the process of water entering into the ground. So if you think about the ground, it's made of dirt, right? Dirt has little pores in between all of the pieces of dirt. Water, being very small, can kind of find its way into those little pores. And water just goes underground, okay? Infiltration, the process of water entering or infiltrating into the ground. Okay? If you've never heard the word infiltrate before, infiltrate means to enter, often forcefully, into something. All right, if you ever play like a video game like Call of Duty or something, and you're playing the story, and they might have to infiltrate into a building. Infiltrate just means to break into it, right? Breaking in is infiltrating. So water breaking into the ground is infiltrating, okay? And as that water infiltrates into the ground, as it breaks into the ground, it becomes groundwater. We're really creative with our names sometimes. Groundwater is, you'll guess it, water that's in the ground. Okay, so as that water infiltrates into the ground, it becomes groundwater, water in the ground, still water, but it's water in the ground. Most of our drinking water is actually groundwater. We get most of our water from underground. It tends to be a lot cleaner than surface water. Surface water is very dirty and very polluted. Groundwater is pretty clean. Okay, so that's where we are on that. So again, here is our little diagram. We've got, starting at the surface.
Mr. John, please.
Yeah, Ethan.
Are we doing the 3-week project today? Right?
No, this is week 4, Ethan.
It is week 4.
Week 4. Yeah, I'm going to go over the projects in 1 minute. So let me finish this up, and then I'm going to go over what we're looking at this week. Okay.
All right.
Okay. So here again, I'm going to go over one more time for you. We've got evaporation and transpiration coming from the ground, going up into the sky as water vapor. That water vapor will condense into a cloud, so it becomes liquid again. That cloud gets heavy, the water starts to kind of drop down to the ground as precipitation. And then we can either run back off into this body of water, or we can infiltrate into the ground, which then also gets us to that body of water. It just takes a really long time. Okay, so that is the water cycle. This is it for information for the week. Tomorrow and Wednesday, I'm going to give you guys work times to work on the water cycle project. So here on Schoology, we have our week four, Ethan, the week 4 water cycle project. Okay, and what this is our Dropbox for the week 4 project. This is the project itself and the rubric. And then here, of course, like all of the other weeks, this is the PowerPoints and the recorded lessons if you want to look back and see what I said. Okay, this week's project, like I mentioned early in the lesson today, is going to be due on Thursday. Okay, 11 a.m. on Thursday. So right before class, so like Wednesday night. Let's get this into me before class on Thursday, because on Thursday, we have our week 4 and 5 project on volcanoes. Okay, we're going to start this on Thursday because it has to be done by next Thursday, August 6th. Okay, I can't get it on Friday. If I get it on Friday, grades are due at noon next Friday. So I need to have it by at the latest Thursday so I can get the grades in. Okay, so because of that little compression of our schedule, I'm going to start that week 5, what was the week 5 project, this Thursday. Okay, and then that'll give you a full week to complete it like you usually get. Okay, so here we got this week 4 project due on Thursday. I'll go over that in a second. And then starting on Thursday, we're going to start our volcanoes research project. Okay, so what this week's project is you're going to document the journey of a water droplet. Your job, you're going to track the journey of a water droplet as it travels through the water cycle. Name your water drop, right? What's its name? It could be literally anything, but give it a name, give it a personality. Tell its story.
Speaking of water, you're turning water off, right?
Yeah.
Just checking.
Sorry about that. You're going to tell its story as it travels through the water cycle. Okay, it doesn't matter where you start. So if you look back on that diagram, this one, you can start at whatever step you want. It doesn't matter. Right? Most people start at evaporation because it's where we think the start of the water cycle is. But you can start as precipitation. You could be like, oh no, I'm falling from the sky. And then kind of go from there. Doesn't matter. Okay? It doesn't matter where you start, but you need to mention all of the stages. Condensation, evaporation, runoff, infiltration, and precipitation. Okay? Notice I didn't mention transpiration there. If you want to mention transpiration, you can, but you don't have to mention it. Okay? Also, tell me how its state of matter changes. When is it liquid? When is it a gas? When is it solid? Okay? So tell me about the processes that you go through, right? Condensation, evaporation, runoff, infiltration, and precipitation. And tell me if it's solid or liquid or gas at any of those stages. Okay? You do got some options for this. You can do this in a couple of ways. Most people opt for this first option here. Write a creative story about your water drops journey. It should be well written, highly descriptive. You don't need to draw anything for this. It's just a creative story about your water droplet going through. I'm going to see if I can put on Schoology. There's a really good Magic School Bus episode where they go through the water cycle, and it's really neat. So if you want to watch that, it's just a really fun episode. I remember watching it when I was in school. If you've never watched the Magic School Bus, you're missing out. Okay. Another thing you can do, you can interview a water drop about its journey. So pretend like you're like a talk show host and like asking the water droplet about where it's been and its travels and how it got there. It can be recorded, or you could just write it up. Okay. You can create a song or a poem or a rap about the water cycle that a second grade teacher could use with his or her students. Second grade teacher, that means it needs to be appropriate. Okay, so if you're making a song, make sure it's appropriate. and make sure if you were singing it to an 8-year-old, they wouldn't freak out. Okay. You can create another comic strip. You can use the same comic strip templates as the last time we did a comic strip about our water droplet journey. Include pictures and words. You can create a video and have the water droplet speak out about its travels. There's something called ChatterPix, which is on self-service, that I think is really, really cool for this. Or if you have another option, you got student choice, just send me a note and say, hey, this is what I want to do, and I'll let you know if it's okay or not. Okay, so you got some choices here. Like I said, most people do this first one, but I have gotten some pretty good ones from these other 4 options as well. Okay. This is our rubric. Content, super important. Do you do everything I ask you to do? Okay, that's content. Okay. Completeness. Does it include all of the stages of the water cycle? Do you tell me about the state of matter? Is it a solid, a liquid, a gas? As it's going on. Do you not just use the word condensation, but you tell me what condensation is? That's completeness. Okay, so this is going to be most of it. This is 15 points. The other 2 are only worth 10 points. So make sure you include all of the phases, make sure you include all the processes. That's your completeness. And your last one here is correctness. Okay, you told me everything. Is it right though? Okay, so that's going to be your last one here. So this is going to be a total of 35 points. Remember, all of these projects are worth the same at the end of the year. So just make sure that you, if you get a 35 on this, that's 100%, which is great. Okay. So this project, like I said, this is due on Thursday at 11 a.m. So before class on Thursday, this has to be done. And then on Thursday, we're going to start our final project. Okay. I know this was a lot of information for today. We don't usually go through this long on these lessons, but I just wanted to get everything done so that Tuesday and Wednesday can just be working days for you. Okay. So do we have any questions before we move on? We're all done for today. So if anybody has any questions, just let me know, type them into the chat or speak them out. And if not, I'll hang on for a few more minutes. But if you think you're ready for this project, you can just get started on the project. Yeah, thanks, everyone.